So we're going to look at systems of equations. Now, systems of equations are any word problems or situations where we have two lines that may or may not cross. In this case, we have two trains. The first train leaves the station at time 0. It's traveling 78 kilometers an hour, the blue line right there. The second train leaves 15 minutes later, so it waits 15 minutes and then starts traveling twice the speed. And it catches up to the first train at this point. So we can see from the two lines that each one is a different train, and where they cross is what we call the solution. The solution is where the second train passes the first train. So if we want to get the solution to this, we just look at the graph and we see that it's at 30 minutes and it passes at 40 kilometers. So we can use the graph as lines to find the solution. Now we have different possibilities. Most systems have two lines that have a different slope. They cross like this one right here, and it has one solution. And anytime we have different slopes, there is one solution. They cross at one point. Now, the problem happens when we have parallel lines. Now, we could have parallel lines with the same intercept. They are on top of each other. In this case, we have an infinite number of solutions because we could pick any point on the line. And the more common one is when we have parallel lines, but they cross at a different intercept. In this case, they never touch, which means they never touch each other. There is no solution. So in most of the cases, we're going to focus on one solution because there's different slopes. So let's try this out. We've got three graphs here. Let's look at the first one. The red lines cross right here. Now we want to try and be accurate. So in this case, it crosses just after the 0 marker for the x-coordinate. So we're going to put 0.1. It doesn't have to be exact, but try and get as close as you possibly can. The y-coordinate, if I count from origin, 1, 2, 3, 4, crosses at 4. That is my solution. Blue lines here, count my x-coordinate, -4, y-coordinate is 2. And the third one, we have two lines, and we have to be able to tell if they're parallel. So in this case, they look pretty parallel in this case. Now, the one thing to remember is if they are not parallel, then we just have to say there is a solution, but we can't tell what it is. It's off the grid. But in this case, we look at it, parallel lines, no solution. The next step is if we're given two lines, we have to start by graphing them. So I'm going to start with that. And once you've graphed them, estimate the solution. And again, it's not perfect. Everyone might have slightly different answers. You could actually have the same answer as your neighbor, but one of you get it wrong. So based on my graph, I'm going to say it's -2, -2, -0.5. So do the best job based on your graph. And if your lines are reasonably accurate, you'll get the right answer. For this one, they're in standard form. So we have to do a bit of work. We're going to find the intercepts, graph the lines, and then find the solution. Now that we've graphed our two lines, we're going to find the solution, count the x, count the y. And there's a solution.